I'd like to talk just a bit about coordinate systems. It's a necessary evil when working with GIS data. All your data have an X, Y coordinate system. Y numbers increasing to the north or decreasing to the south, and X numbers increasing to the east and decreasing to the west. They're sometimes called eastings and northings. Now, when I load data like these Minnesota State County data, they come with a predefined coordinate system. I look down here along the bottom, I can see the actual coordinates, and that's wherever I'm roaming the cursor. It tells me the coordinates in my current system where I'm holding the cursor. So you can see as I move here, that first number, that X, gets bigger, and as I move to the north, that second number gets bigger. Those are the X and Y coordinates. And the coordinate system number is down here in the corner. Now, I can go and look at my current coordinate system and its name by going up into Projects, Properties, and that will open a window under the CRS tab. It will list my current coordinate system. This is the Entity 83 UTM Zone 15 North coordinate system. Now I want to show you that if I switch to a different coordinate system, this WGS 84, which is a common geographic coordinate system, it changes the shape of things. And I'll explain it in a few slides here. So most of us are familiar with this latitude and longitude coordinate system. We have these longitudes that go, lines that of equal longitude go in the north-south direction. This is the prime meridian, the 0 longitude. And as I go in this direction, I get these negative longitudes. We're at about minus 90 longitude here in Minnesota. The latitudes increase as I go north. So 0, 15, 30, 45. We're pretty close to 45 degrees north. So we're here 90 west or minus 90 degrees and 45 north or plus 45 latitude. The reason we can't use these in a GIS is that these longitude lines converge and cross. So distance on the surface of the Earth of 1 degree of longitude is different up here near the pole than it is down at the equator. And we want area to be area everywhere. The same square area should cover the same amount of ground both places. And if we tried to measure them using latitude and longitude, that wouldn't work. So we use these projected coordinate systems, Cartesian coordinate systems. You all know these. They're basically parallel lines in the north-south and east-west direction. They never converge, and so an area one place or a direction or distance is the same as an area another, and you often see them on maps. And there's a process to go from one to another, to go from this curved surface and the points of things on this curved surface onto a map, and it involves some distortion. So for a conic map projection, we project from the surface of the Earth down onto a cone, and so this is our latitude and longitude grid on the cone, and then we mathematically slice and unroll and then stretch out the cone, and so you could see we get some distortion up here near the north. Now we can control these so that within the area mapped, the difference in an area of a grid up here and an area of a grid down here is negligible. We just map over a bunch of small areas. That's why we have map tiles. But the main point is different projections, different ways of going from that curved Earth surface, latitude, longitude, to a Cartesian surface distort the shape or direction or areas in different ways. And we want all our data in the same one, and in one that distorts it relatively little in our working area. Now for Minnesota, that is this UTM N8083 coordinate system for the whole state, the one that I chose initially. So if I go to my project and properties and select this N8083 UTM Zone 15 coordinate, that has the least distortion for the whole state. And if I'm working with statewide data or large regional areas, I'll use that. There are also standard county coordinate systems or state plane coordinate systems that, if you're working in an area, you may be required to use. I can look those up. So for example, if I go back here to my projection properties, I can type in Minnesota and it'll list a bunch of projections for Minnesota. Basically, the main thing you need to know is you want everything in the same coordinate system, and you want one of these coordinate systems that doesn't distort the data that you have over your study area. And for us, for most of the time, that's this UTM N8083 Zone 15 North coordinate system. If you have a choice when downloading data, you want to use that most of the time. As you get better with GIS, you may branch off into other coordinate systems or know when to use them.